Hello everyone and nice to meet you. My name is AidenTeachesMath and today we're going to look about telescoping, and it's for grade 10 students in America, and it's probably inside algebra, and I do not know because I'm South Korean. I do not know anything about the American math education system, but anyways, it's probably in grade 10 algebra as I know, and I am going to talk about this telescoping in a very fun way. So today's lesson, we're first going to learn about telescoping, second, and examples, and third, chit-chats to remind. Firstly, let's talk about telescoping. So, as we know, telescoping is, you know what a telescope is, right? Telescope. It's a thing that becomes longer like this. So this is what we do. We go out, you know what sigma is if you're grade 10, right? So let's go like sigma I equals 1 to 1,000. I, 1 over I minus 1 over I plus 1. Then, this is just a simple question. So, probably most people will just, as a question, do this, but we can change this to I under 1 minus I plus 1 under 1, and if we sigma that I equals 1 to 1,000, then it becomes 1, 1, minus 2, 1, plus 2, 1, minus 3, 1, plus 3, 1, on, and it becomes bye, and at the end, there's only this left, which becomes 1001 under 1000. So it's just like going a lot, and it's like something minus something, and something minus something, and something minus something, and this is same, but this is minus and this is plus, so this becomes x, and this also x, and minus, and at the end just becomes this minus this, so this is probably something, and this is called telescoping. Let's get to an example. Sigma n equals 1 to infinity, but let's change the infinity. I just made the PDF, but let's just change it to 100. I don't care about the question because I made the question. You don't need to care about it. So we just change it to 100. Okay, so you know this is 100, right? This is not 1 infinity. And n plus 2 under 12 equals, this is n under 1 minus n plus 2 under 1. But this is n plus 2 under 2. So we need to times 6 on this. So let's times 6 on here. And we can't forget our sigma n equals 1 to 100. And this becomes n equals 1 to 100. So this is 6 sigma n equals 1 to 100. N under 1 minus n plus 2 under 1. Which is the first 2. 1, 1. 2, 1, minus last 2, 101, 1, minus 102, and 1. So if we actually calculate this becomes critically hard to calculate, but anyways, let's just calculate it by our things, and 101 times 102 equals 10,302. You know that x squared plus 3x plus 2 equals x plus 1 times x plus 2, so this is 10302, and this is 10302 under 10302 plus, what is it? 10302 plus, let's just do it this way. This is 2 under 3, so this is 9 plus 101, 102, so which becomes 10302 under 203. So if we times 6 on this, 10302 under 1218. Okay? Understand? So 102, actually 101 times 102 is actually 101 times 6 times 17, right? Yes. And this is 203 times 6. So this is actually 9 and 1717 under 203. And in American algebra, and both in Korean, Chinese, Japanese algebra, we do not use like this method. We do not write in this format of, I don't know what this, what's this called? Fractions? Yeah, fractions. Probably. Yeah. We write it as 1717 under 1717 times 9 plus 203, which actually becomes 1717 under 15656. Oh my god. So 1717 under 15656 is our answer. Or you can write 91717 under 203. Now, let's go to a reminder. This is really important. Telescoping is in grade 10 of American algebra. This is American. I don't know about the English, British. Yeah. So just think of American art of problem solving algebra book of grade 10 that has telescoping, and it's going to turn about sigma n equals 1 to 100, n times n plus 2 under 12, and it's actually going to be 1717 under 15656. Okay, so let's do a reminder. What is telescoping? Telescoping is just really telescoping. You go in small, bigger, bigger, bigger. But this is all the same. So this goes away, this goes away, goes away, goes away, and only goes away this much. Everything goes away. The same thing goes away. And the only thing left is the start and the end of 2, 3, or more, maybe 100, because n plus 1, n plus 2, to n plus 100, under probably 100, n plus 5050 is going to be something like that. And I do not know what I'm talking about. And it's still going to be something like that. And I'm not sure. I don't know how to times 99n plus something. Okay? I'm not sure. I can't calculate that. I'm not O from alpha. And I'm telescoping, and I'm using these examples, and something you should know is that I did not tell you, but let's say n squared plus n plus 1, and n squared minus n plus 1. Let's do k squared plus k plus 1. And if in this thing we put n plus 1, k plus 1 in n, then it becomes k squared plus 2k plus 1 minus k minus 1 plus 1. And this becomes plus 1 minus 1, what becomes just 1. Let's go like this. Right. So this goes away, and 2k and minus k, so k squared plus k plus 1. So what I mean is, if fk equals k squared plus k plus 1, and gk equals k squared minus k plus 1, fk equals gk plus 1. And this is really, really, really extremely important American algebra. Grade 10 algebra always talking about n squared plus n plus 1 and n squared minus n plus 1. And also, I'm going to tell you a skill about changing numbers into variables. And I do not know why, but we should still do something like that. So something like this. Cubic root of a plus cubic root of a squared plus a plus cubic root of a plus 1. Is this correct? Actually, this is not correct. Okay? This is actually not correct. What I'm trying to say is this. But anyways, what is this? I don't even know this. Okay? This is third root a plus third root a plus 1 all squared if you have 2 under here. Okay? So, I mean, like, third root a plus 1 squared. Third root a squared plus third root a squared plus 2a plus 1 plus 2 third root a squared plus a. Here. So this is third root a plus third root a plus 1 under 1, which becomes what? This is going to become something. Actually, I should not do it like this. But anyways, let's say something like third root a plus third root a, this doesn't make sense. Anyways, but let's say third root a times third root a plus 1. Do not think about this is nonsense. Anyways, like this. We can still use cubic roots, quadruple roots, pentaroots, hexaroots, octaroots, decaroots, a lot of roots. I do not know. People use a lot of these. And also, with these telescoping things, we also use a lot of arithmetic means and geometric means and harmonic means. You know what they are? AM, GM, HM. Probably on grade 10 or grade 9. Remember this, and this is when A1 equals A2 equals ... equals AN. Okay? Need help? Message me. Email me on AidenTeachesMath@gmail.com. You did great. See you next time. This was Aiden Teaches Math, talking to you about telescoping in grade 10 students in America going one step near to infinity.